All right, so continuing with our right-tailed test, we already saw that it was important that they do the same dates to ensure that season and time and such were not confounding variables. This is a right-tailed test. You can tell because in the problem it says something to the effect of, does the evidence suggest that clarity is improving? Improving, i.e. getting better, i.e. going, right? Sorry, 590 right there. So clarity improving. So this is a right-tailed test. So I've already got that. Then you need your alpha, which we already have. It's given to you as 0.05, typical, right? Then you need your test statistic, T0. I'll just type that in right here. Okay, that's equal to, oh, we're going to need some D bars. All right, so we better go over here. I forgot about that. D bar, we need SD, and we need N. Okay, so D bar would be equal to the average of the differences. Uh-oh, we don't even have differences. Okay, so we need the differences. Since we want to know if it's improving, we want to take the newest data minus the oldest data. And we want to do that through all of them. And then D bar, SD, and N, those would be equal to, whoopsie, equal to the average of those numbers, and then equal to the standard deviation dot S. And again, if you don't have the newest version, it's just STDEV with no dot S on it. And then count of those numbers. There we go. Okay, so the test statistic is equal to D bar, which is that number, divided by parentheses SD, divided by SQRT of N, close parentheses, enter. There's your test statistic. Beautiful. All right, step 4. I'm going to continue to show you both ways because that's just how I am. So we're going to need the classical. All right, so you're going to need critical value. Critical value. Now, how do you find it? Well, trickily. So in the new Excel, you type T dot inverse, right? And you say, okay, I want that probability. Degrees of freedom is 8 minus 1, right? Wrong. Okay, the problem is that T inverse always is left-tailed, so you can do this, you can fix this a couple ways. You can do 1 minus 0.05, that'll give you the positive one. Or you can do 0.05, but then just take the negative of it, right? Because you want a right-tailed test, because this is a right-tailed test. So either way, do the negative in front or do the 1 minus in here for your area with the alpha. That's fine. In other words, 1 minus alpha. Whatever. Now, old school Excel, you got to do T inverse. Okay, you've got to multiply it by 2 because T inverse in old school Excel is always two-tailed. Then you tell it degrees of freedom, which is 8 minus 1. Okay, there we go. The good news for that one is that it always gives you the positive one, which is bad for left-tailed tests, but good for right-tailed tests. All right, so you can see we're going to reject, right? Hopefully. Step 5, reject H naught because T0, which is equal to 2.384, is greater than T alpha, which is equal to 1.895. All right, so that's the classical way. What about the p-value way? That's equal to T dot dist dot RT, because it's right-tailed, see? Test statistic, comma, degrees of freedom, 8 minus 1, enter. There's your p-value. Now, old school Excel, it's going to be equal to T dist. And you say 2.3 blah, 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 degrees of freedom, 8 minus 1, comma, one-tailed. There we go. We've got it. All right, so I'll meet you back here to finish this problem out, and we'll be all done.